Assalamualaikum warahmatullahi wabarakatuh. In this video, I will be explaining about FM generation, direct and indirect method. So for direct method, there are three methods under the direct method, which are the varactor diode, voltage control oscillator, and also reactance modulator. So we will start with the first one under direct method, which is the varactor diode. So the varactor diode is used in tuned circuits to adjust the center carrier frequency to a suitable level. The diode is back-biased to provide junction capacitance, but it varies depends on the voltage. In this case, C is equals to K Vm, and when Vm equals to 0, Fo equals to Fc equals to 1 over 2 pi square root of Fc. The C value is very high, so the reactance will be very low. The capacitor connects the tuned circuit to the oscillator that will block the DC bias from getting shorted to the ground through L1. So L1 and C1 will determine the center carrier frequency level. So the whole purpose of varactor diode is to adjust the frequency to a suitable level. So from the equation, F out equals to 1 over 2 pi square root L CT. So CT is equals to C out plus C. So when we substitute the CT inside the equation, we will get 1 over 2 pi square root L C out plus C. So when we simplify, we will get 1 over 2 pi square root of LC multiplied with 1 plus C over C out, power of negative half. By using binomial expansion, we can simplify 1 plus C over C out, power of negative half. If C over CO is small, we can get 1 minus C over 2C output. So the final equation will be FC multiplied with 1 minus KVM over 2C out. The second method is voltage control oscillator, or we can call it VCO. So a VCO is an oscillator where the frequency can be controlled by an external voltage. In a VCO, the oscillation frequency will change linearly with the control voltage, which means that it is directly proportional. The instantaneous frequency of a carrier wave is varied in accordance with signal MT, amplitude variation, by using VCO. Next, we will move on to the reactance modulator. Reactance modulator is a circuit operated by a transistor or FET as a variable reactance, capacitance or inductance. So it is placed in an LC circuit. As the modulator reactance changes according to the applied audio signal, the oscillating frequency also changes. So in this diagram, it shows that this capacitor and inductance is used. So all three of the methods that I mentioned just now, the varactor diode, the VCO, and also the reactance modulator, have similar problems, which is they do not have the mechanism to prevent frequency shift. So the signal is not stable. So the crossbar modulator is used, and it uses the crystal oscillator, which is stable but it has high current, so the frequency cannot be changed directly. So the crossbar modulator will be used, and it also uses the automatic frequency control to control the frequency so that it will be stable. So in this diagram, you can see that the crystal reference oscillator is used, and it is added into the system to provide stability. I will move on to the indirect method, which is also called the Armstrong method. So this method is obtained through the signal. So the signal in this method is obtained through phase modulator, which produces message signal in instantaneous wave, and it also uses the crystal oscillator for stability. So crystal oscillator will create electrical signal with precise frequency, so it will be stable. So I will now explain the modulation using the Armstrong method. So the source of carrier of the Armstrong transmitter is actually the crystal oscillator. It is relatively low frequency subcarrier, and it is phase shifted by 90 degree and added to a balanced modulator mixed with the input modulating signal. So in this diagram, you can see that the signal from the crystal oscillator will go through a 90 degree phase shift, and then it will be inserted into the balanced modulator, where it will be mixed into the modulating signal. At first, a double sideband suppressed carrier wave will be produced at the output from the balanced modulator, but then it will be combined with the original carrier from the in the combing network to generate a narrowband frequency modulation. So the narrowband frequency modulation, NBFM, is practically the same, similar to the double sideband suppressed carrier, the SBSC, but the lower sideband is inverted. Lastly, the phase of the carrier is directly modulated in the combing network through summation, generating indirect frequency modulation. The magnitude of the phase deviation is directly proportional to the amplitude of the modulating signal, but it is independent of its frequency, which means that the magnitude of the phase deviation is affected greatly by the amplitude, but it's not affected by the frequency. That's all. Thank you.